And these are the features are unique in the industry that includes the encrypted traffic analysis, the proactive attackers block, the IoT sandboxing solutions, and also the cloud workload protections. So I'm not going to explain them individually. Instead, I'm going to explain them in a scenario basis over here. So a couple of scenarios I'm going to mention. The first one is internet facing, followed by the air gap environment and the cloud environment. So first one, internet facing scenario. So first of all, let us just quickly understand how the malware works, right? So there's a gullible user in your environment, download the email attachment. Unfortunately, the email attachment has a marcode that is embedded, which is a executable file. And then the malware will trigger C2 communication or command control communication to the outside, for example, hacker, and to get the installer file downloaded. And this particular installer file is going to trigger another C2 communication, right, to get the actual malware, which is the dropper.zip downloaded. And actually the dropper.zip file will contain two different files, right? The first one is the persistent DLL, which is to make sure that the system or the PC will always load the malware when it boots, right? So the other part is actually to encrypt it, the information, the sensitive data, right, that the bot or the malware is going to send out to the hacker on a timely basis to perform the data exfiltration. And to highlight over here, all the communication nowadays are over the TLS or is encrypted. So to understand from the very high level, to simplify the scenarios over here, basically how a malware works is the bot master or the hacker will try every way, right, to inject into your system, to elevate your system, they become for example, the bot, and the bot will establish, right, the CNC command control server communications via the encrypted channels over here. So basically, this is how a typical malware works nowadays. So in order, right, to mitigate that, Juniper has recently developed a feature that is called the encrypted traffic analysis without using the SSL proxy. If you're familiar with the SSL proxy, you might be knowing that it's notorious performance degradation after it's turned on, right? More than 50, 60% of the performance degradation. So we try to do away from that using a different approach, which is the AI and machine learning, leveraging our cloud or SKYATP solution. So later I'm going to explain the nitty-gritty or the detection mechanism of this particular feature. But now let's move on to the other feature, which is also very unique in the industry, which is the proactive attackers block. So it's pretty easy to understand, right? So just to block the attacker proactively before the attacker even reach out to you. So basically how it works is, over here, where we have a couple of the SRS or MS router set up in a distributed manner across the world, right? Whenever an SRX device detects, for example, an attacker is trying to brute force your website password, right? And it's captured by the SRS unbox IPS. And the SRS unbox IPS is going to mark down the attacker's IP address. And immediately, with this particular feature, the SRS is going to send the attacker's IP to the SKYATP. And the SKYATP is going to inform the rest of devices that join the same domain that, hey, this is the attacker's IP. Please pull up an ACL immediately, right, to block that. So basically, this is how a proactive attackers block feature works here. So let's revisit the feature I mentioned earlier, right? Encrypted traffic analysis, how it works. So over here, we understood that, hey, the traffic, the packet payload is encrypted. There's no way that we can look into it to inspect it without using the SSL for proxy. That's true. However, for a TLS communication, it requires the handshake stage, right? To exchange, for example, the certificate information, right? The cipher suit the client and server is going to negotiate to use. For example, are you going to use RSA or DEFI human, right, for the key exchange? Or are you going to use AES-256 for the symmetric encryption? or what hashing algorithm am I going to use? I'm going to use like SHA-256. And apart from that, right, they're going to exchange the certificate, right? So for example, the certificate details like the expiry date, right, whether the certificate is considered malicious or not. And apart from that, we understood that those C2 or command control server communication has certain traffic pattern. For example, for the data extraction, right? The malware is going to send out information on a timely basis. So for all the kind of information, the details, are going to wrap all the metadata the SRS has collected into a very small file and stream the file to the cloud for analysis. Right, the cloud is basically the SKYATP. Right, we have like 100,000 of training data set to be used for training the AI and machine learning engine in order to detect like such malicious communication. So with that, right, the cloud AI engine is going to come back with verdict telling you that, hey, it's considered malicious communication. SRX, please block that user, block that attacker immediately. So basically, this is how encrypted traffic analysis works for a C2 communication block. It's done without using the SSL forward proxy. It's done purely leveraging on the metadata collection, AI, the machine learning. And a different scenario is regarding the malware scanning, which you might be more familiar with. Right? It's just a typical unknown file, how the SRX treat it. So if it's a known file, right, the SRX will do is, okay, I haven't had that matched on my unboxed signature database. What I'm going to do is I'm going to send a chunk of the file, basically, for example, first 32 bytes of the file onto the SKYATP. So what the SKYATP will do is we're going to do a cache lookup to see whether the file has been scanned by other SRX in the same domain. If not, and then I'm going to perform an antivirus scanning by using multiple antivirus engine. And if we still can't find anything, then I'm going to use the AI machine learning engine, right, to perform the static analysis. And over here, the metadata I'm going to analyze to extract from the file is, for example, if it's a Word document, hey, I only see one liner of the content, right? It's very suspicious. And it's a Word document. Once it's open, hey, how come it's pointing to a DNS server? Right, very suspicious. Or, right, it's a spreadsheet. There is an executable file embedded into the Excel spreadsheet. Very suspicious. They're going to perform this level of a static analysis by analyzing the metadata of the file. However, if we still can't find anything, then we're going to send to the last result of the scanning, which is the sandboxing, right, to perform the dynamic analysis, to run the file, right, to see what happens. And on the other hand, right, we have another, which is called the SECINTEL, which is our central database, right, on the cloud to store the infected host information and also the threat details, so that all the infested host information could be distributed to every single point of the network, including the SRX, including the MIS AP, including the MX router, and also the EX secure fast switches. Talking about the MIS, right, like Andy Wong just mentioned, right? So it's AI driven, and the MIS portal is integrated with our threat prevention or the SKYATP already, which means that whenever a threat is detected, infected host is identified. It will not just show up our SKYATP portal, but also on the MIS portal, right? You can see, hey, who the user is, the user details, and you can even locate the particular infected host on the map. And most importantly, on the MIS portal, we can show you the threat details. Right? For example, it's actually trying to establish a communication with the outside CNC server. And as a network administrator, you are given the option to block the user on the MIS portal with one click of the button. And apart from that, recently we have just launched another feature, which is the DNS protection in our latest Junos release 21.2. Right? In terms of the DNS protection, two perspectives. The first one is the DGA generated domain detection, and the second one is the DNS tunneling. So over here, it's just a showcase of how it looks on our SKYATP portal. So for DGA, right, those randomly generated domain name, that is to confuse the security analyst, right? Only like 2 out of the 100,000 of them will point the victim to a C2 server. And the other one is the DNS tunneling, right? That is used for the data exfiltration, right? Because the TCP port 53, right, used for DNS query is never supposed to be used for the tunneling, right? So we introduced this ARM box feature on SRX in the latest release 21.2. Okay, here is the second scenario, which is the air gap scenario. So air gap scenario is referring to an isolated environment where your client could be a bank, could be a government institute. They will only like allow intranet or WAN connectivity. So over here, SRX is still the center of the universe. They're going to perform the file scanning, right? Going to be integrated with, for example, the Juniper SIEM, we call the JSA Juniper Secure Analytics. Or we have a light version of Juniper SIEM, which is called the Juniper Director Insight. Later, I'm going to introduce it. And for the unknown file, of course, we're going to send the unknown file to our on-prem ATP solution, which is called the JATP, right, to perform the zero-day scanning. And of course, I mean, most of the clients have the endpoint protection solution installed. For example, the Kaspersky, CrowdStrike, Carbon Black. However, in the isolated environment, hey, they give no option for the zero-day scanning, because a typical way for them is to send the unknown file to their cloud. However, here you don't have the internet connectivity. So that's why our JATP given the option for them to be integrated, to submit a known file in an isolated environment to perform the zero-day scanning, right? Where we have the AI and machine learning and sandboxing embedded into the box. And then once we identify, hey, the file actually is malicious, we're going to tell the endpoint protection solution to block the particular file, the particular user via the API. And of course, all the patches down to the JATP is considered offline. And our JATP is going to send the infected host IP to the Juniper security controller, or if you are familiar with, it's the Juniper policy enforcer. So basically what a Juniper policy enforcer do is to translate the infected host IP to a MAC address so that our switch or the AP is able to block the host on the edge, right? Because you have 100,000 of access switches that don't understand IP address at all. And nowadays, the malware, like the recent notorious one, Murai, is replicating themselves over the access switch via, for example, the SMB CIFS protocol. And this is considered the lateral movement attack. So with the MAC address block, it can give you the effective protection against those lateral movement attack. And the reason that we will have this feature in place is having another consideration that, okay, we don't trust the endpoint protection fully, because we understood that there is a boot over the, for example, the operating system kernel, right? If your operating system is compromised, highly likely that your endpoint protection solution is going to be compromised, it's going to be bypassed. So it's not 100% secure. With that taken into consideration, this MAC address block to totally isolate your infected host becomes the last resort of the protection in your environment. And of course, it's Juniper unique solution, the connected security. And this feature is just to give you the update of our signature package, right? They are all IoT ready now, like our application control, the IPS, the sandboxing, and also the ATP. And also, in terms of the sandboxing solutions, we're not just analyzing, right, those applications running over the Windows, the Mac OS, but also the Linux. And it's not limited to those applications running over the standard Intel x86 architecture, but also the MIPS and ARM, which is the mainstream for the IoT devices nowadays. Other vendors may claim that they can run the sandboxing over Windows, Mac, Linux, but very few of them actually can perform the sandboxing analysis for these two CPU architecture applications. And of course, we have a new product that is called the Security Direct Insight. And we treat it as a SIEM-like solution. And of course, the costing is also very friendly. So basically, that extracts the core functionality of the full-fledged SIEM, which is extremely expensive, which is the log consolidation and the correlation. So the Juniper Direct Insight can not just only ingest and collect the logs from the network devices like the switch or the router, but also the endpoint protection solutions like Carbon Black, Kaspersky, McAfee, and the third-party firewalls like Fortinet and Palo Alto. And you're given the option, right, to filter, to sort, to correlate, to define the root and severity, and to customize alarm alerts to help you simplify the log views. So for example, you're not just receiving the logs from 5 different sources telling you the same thing, right? Instead, you're only seeing one, because with this SIEM-like solution, right, it helps you reduce the noise, give you a better accuracy for example, your in-house security analysts. And of course, I mean, the business value of our AI-driven connected security solution. So before and after, right? Before it's implemented, everything is done manually, including the threat mitigation. So whenever a threat is detected, right, your network team and the firewall team is going to point finger at each other. Yeah, it's not my issue, it's not your issue, etc. Right? After a few days, it will be mitigated individually by each of them. Not very efficient. However, once you have our Juniper Connected Security implemented, where the Juniper Policy Enforcer is in place, whenever a threat is detected, the Juniper Policy Enforcer is going to instruct every single network device to block the threat immediately, including the AP, the SS switch, the core switch, and also the firewall device. So everything will be done automatically, mitigated automatically, just within a few seconds. So there will be no finger pointing in your environment, instead more harmony. And last but not least is the cloud environment. Recently, we have launched a new product, which is our Juniper Cloud Workload Protection Solution. So in terms of the workload protection, the first thing come into your mind is definitely the WAF solution, right? However, our approach is slightly different. Our solution is considered a RASP solution, if you're familiar with the term, right? It's Runtime Application Self-Protection Solution, right? So the WAF is a traditional parameter defense, right, to secure your web application, right? It's pattern-based, it's signature-based, it's regular expression-based. However, the RASP solution, what we need to do is just simply install an agent onto each of your workload, and it gets you the protection against those like OWASP top 10, like SQL injection, cross-site scripting, the memory-based attacks like buffer overflow, stack overflows. It's real time, and it can help you highlight those vulnerability that is detected in the runtime. So the key differentiators of our workload protection solution is the first one, right? The zero-day attack protection, and it's true zero-day attack protection. Why? Because comparing to WAF, right? It's a signature heavy and it's leveraged on the pattern. So that's why you need to update your signature pack on a timely basis. For our solution, we leverage on a different technology that is called the CFI, the control flow integrity, and we optimize it. So how it works is, I mean, in layman term, it just sort of like a benchmarking solution or before and after, right? So we're going to run the application together with our agent in a clean environment once to let our agent fully understand how the application code works. Basically, to record the validated return address of each application calls and the functions. And we're going to store them into a small chunk of the memory that we call a shadow stack. So over here, we're going to store all the validated return address of each call and functions. And then after the application is put into production, and now we're going to validate each of the return addresses of the calls. So for example, the return address is 0x000000A. However, in the production, it becomes B. Then we know that, hey, there's some deviation or manipulation done to the code. Likely there will be an attack. And then we're going to block the particular activity. So it's a true zero-day attack protection. After you get the agent installed in a clean environment in day one, you get a peace of mind. And apart from that, of course, the complete visibilities get you protect against those OWASP top 10 attacks, and also the memory-based attack protection like buffer overflow, like stack overflow, heat overflow, etc. Can be easily mitigated. Last but not least, I would like to highlight our security efficacy validation from third-party institute, like the NSS Lab, which retired in 2019. But at that time, we are one of the top already, right? We beaten Cisco and Palo Alto. Huawei checkpoint didn't compete. And another lab, which is called ISC Lab, right? We are the top one. We had the 100% security efficacy against those like exploits, malware, malicious URLs, and we beat Fortinet. And this three didn't participate. And the descendant, right, of the previous NSS Lab, which is the Cyber Rating, which is founded last year, same founding team of the NSS Lab, and we participate last year, and we are considered one of the best vendor, beating Cisco, Palo Alto, Fortinet, and Checkpoint. Zscaler didn't participate. So that's all for my presentation. So if you have any questions, please feel free to drop your question into the Q&A box. Thank you very much. Stefan, over to you.